Hi, my name is Solomon, and today I will walk you through how to get started doing SLAM on your Interbotix LoCoBot. There are three ways to run the navigation stack. Either you can build a new map from scratch, continue mapping from a pre-existing map, or do localization only. For this tutorial, I will be SSHing into the LoCoBot computer over a network, and I will specifically be using the medium type of network setup, which I discussed in a previous video. What this means is that you should have the remote software packages installed on your personal or remote laptop. Okay, so let's get started. First, open up a terminal by pressing Ctrl-Alt-T. And you will also want to connect to the network that your LoCoBot is connected to. In this case, I'm already connected. I decided to broadcast a hotspot from my LoCoBot computer. This is not something that is done by default, but it is something that you can do yourself. Otherwise, if you want to get a dedicated router that you can connect your LoCoBot to and all other computers that you want to use to interface with the LoCoBot, you can do that as well. Okay, so then what you're going to do is type SSH-X LoCoBot at LoCoBot.i.local. So the -X flag allows you to do window forwarding. This means that I can run small GUIs on the LoCoBot computer, and it will be forwarded. The whole GUI will be forwarded to my personal computer, so I can see the GUI on my personal computer. Something else to note is that I'm using LoCoBot I. This is because we have lots of LoCoBots in the office, and in order to differentiate between the one I want to connect to and all the others, I've decided to change mine to LoCoBot I, the host name, to change it to LoCoBot I temporarily. But in your case, you will always be SSHing into LoCoBot at LoCoBot.local. Okay, press enter, then press yes. The password is LoCoBot, and we are in. Then type GNOME. Well, actually, before that, let's connect the PS4 controller. There are different ways you can control the LoCoBot. I found that for mapping purposes, it's just a lot easier to use a PS4 controller. You have more control over how the LoCoBot moves. You can also use your keyboard to control the LoCoBot. It's a little bit less intuitive than using a PS4 controller, but it still works. And if you don't have a PS4 controller, it definitely is better than nothing. Okay, so to pair your PS4 controller with a LoCoBot computer, type sudo bluetooth ctl. Password again is LoCoBot. And here's a handy command to note, devices. What this will do is normally it will return a list of Bluetooth devices that have already been connected to the computer in the past. In this case, there are none. So not even the PS4 controller that we want to connect. So let's do that. Type power on, agent on, and then scan on. The scanning functionality, once I press on, means it'll start looking for new Bluetooth devices. So what we're going to do is, using your PS4 controller, hold down the share button, and while you're holding down the share button, hold down the PS button until you see the white LED at the top there start flashing like it is right now. At that point, you should start seeing an option on your Linux device called wireless controller. Here we go. And what you're going to do next is type connect, and then you can type like the first two numbers or something of the MAC address, and then click tab, and it should auto-complete for you. So press enter. Once you press enter, you should see the LED on the PS4 controller turn to blue. And then what we're going to do is one other command, which is trust, and then type your MAC address or the first couple letters, and then press tab to autocomplete. And what the trust command does is, currently, if you turn off Bluetooth functionality between your PS4 controller and your computer, and then you try to connect again, it won't work. Because there's no trust between the Bluetooth controller and your computer. So in order to make sure that no matter how many times you connect or disconnect from your computer, you want to make sure to set the trust command. Okay, so type quit, And now we're done with the PS4 controller setup. Just to make sure that your PS4 controllers will actually pair again once we disconnect it and then connect it again. Let's just hold down the PS button. This will take a few seconds to disconnect. You'll know it's disconnected once the LED turns off. Okay, it's off. Now just tap it again, and then the white LED should flash a few times, and eventually it should turn blue. Just like that. Okay. Now type gnome terminal ampersand. What this will do is open up a small GUI on the LoCoBot computer, and then through window forwarding display it on your personal computer. And you can open up as many tabs as you want on the LoCoBot computer from this terminal instance, which is not the case here. If I open up a new terminal here, it'll be on my personal computer, and I would have to SSH again into the LoCoBot computer if I wanted to do anything on the LoCoBot. So that's why we're going to use the GNOME terminal here, this command to specifically have terminals available to us on the LoCoBot computer. All right, so let's launch the navigation stack by building a new map from scratch. Let's type ROS launch, Interbotix, XS LoCoBot, nav, XS LoCoBot nav.launch, robot model is equal to LoCoBot WX200. If you're using a different model LoCoBot, you would just put it in there. I'm using a LiDAR, so I'm going to set it to true, but by default this parameter is false. So if you don't have one, you could just omit this whole part of the command. And then rtab map args is equal to -d. So by default, rtab map ROS is what we're using to do SLAM, and it keeps all its data in a database called rtabmap.db. This is what it uses to build its, a map at runtime of your environment. It also has all your point cloud data and lines that are representing where the robot has been. So, like I said, by default, this is stored in your home directory -ros/rtabmap.db. So when I type this command, it'll delete that file and start a new one. So you want to be careful about this, that you don't overwrite something you don't want to overwrite. And that's where a different command comes in. There's a command called database path that you can set as in your launch file argument or in your terminal here, where you could specify a path where you want to save your database. So if you want to work with different databases, you could just use that database path launch file argument to specify where you want to store it. Okay, but for us, we're going to just store it in the default location. So press enter. You'll also want to make sure that your Kabuki base is on and that all your sensors are plugged in, or this won't work. Once you start seeing this message here at a rate of about 1 second from rtabmap, you know that it's doing SLAM. So now let's start the PS4 control package. So press Control-Shift-T, and we're going to type ROS launch, Interbotix, XS LoCoBot Joy, XS LoCoBot Joy.launch, robot model is equal to LoCoBot WX200. Again, if you're using a different model, you would put that here. And then you would write launch driver is equal to false. So by default, launch driver is true. And what that argument does is if it is set to true, it'll launch the ROS, the Dynamixel ROS wrapper. But since we've already started that when we started the navigation launch file in this terminal, there's no need to start it here. And again, if you were to start it, you would have issues. So don't do that. Press enter. Okay. Once you see this command here about the gripper XS interface being loaded, then you know that you can start controlling your robot with the PS4 controller. Before we do that though, let's first open up Rviz on our personal computer. So we're going to go here, press Control-Shift-T, and this will open up a terminal on our personal computer, which is called DemoComp. And we're going to type ROS launch Interbotix XS LoCoBot descriptions, remote view.launch, And then we're going to set the Rviz frame to be map because we're doing navigation. So everything is going to be with respect to the map frame. All right, so now let's do a little bit of configuring here. And I'll walk you through these parameters. So first parameter here is map. So the map, anything that is like open space, clear space over here, that means to the best of the robot's sensor knowledge, there is no obstacles there. Anything that is black means there is an obstacle there. So since we have a 360-degree LiDAR, we can get instant feedback on all that without the robot even moving, which is awesome. And the topic we are listening to for that is, let's just make this a little bit bigger, LoCoBot/RTAB map/grid map. Okay, and this is already pre-configured for you, so you don't have to do it yourself. Now let's look at the camera. So if we check that box, we'll have both a live feed from the D435 camera that's on the LoCoBot. So if you wanted to see from a first-person type of view of where the LoCoBot is as you're controlling it, you can definitely do that. So next we have the Point Cloud 2 display. Right now, this isn't going to be displaying anything just because we don't have the functionality turned on. It is not actually needed for to do navigation. It's mostly there for if you're working with perception, then you can see what the raw point cloud is. Okay. We're going to keep the image on though. Laser scan, so that will show you those red pixels over there. Will show you what the 2D laser scanner is seeing, and pretty much it's supposed to pretty much overlay where the black pixels are in the map, because that's what are considered obstacles. Okay, then we have our tab map ROS. So if we click that, so we start to see something. So the info message, that's just messages to let us know about different things regarding the map. We don't really need it. It's more for debugging purposes. We have map cloud. We'll talk a little bit more about this. Well, actually, talk a little bit about it now. So we're going to put this here to the left. And here are some tips, just general tips to doing navigation. One of which will be something in this map cloud display. So we'll get there, but let's just start with the first one. When it comes to doing navigation using the PS4 controller or just in general, my recommendation is to rotate the robot in a full circle slowly so that you get as many features as possible, and so that the algorithm has a higher chance of getting loop closures. Once you finish rotating in a single spot, then you want to slowly translate over to another spot and do almost another full circle, enough so that you don't necessarily look back at what you've already done, but enough so that there's a little bit of an overlap between what's new and what you've already mapped. And then you want to repeat this translation, moving the robot and then doing a circle as many times until you've mapped out your whole entire area. Now in the RTAB app ROS Rviz display, which is what we are looking at, you can open up the map cloud display and raise the cloud decimation level to 6 or 8. And the default is 4. So if we go here, we're going to go to cloud decimation, and we're just going to change that to 6. So I don't know if you caught that, but when it was at 4, it was a little bit more detailed. There was more pixels there. And then once I put it to 6, it's a little bit less. So here's 4, and here's 6. And the reason for that is by making it a little bit higher for cloud decimation, you lower the chance of there being noisy pixels. Okay. And then another thing to point out is that the cloud max depth level, you can set that to 2. So here, we're going to put that to 2. Right now, it's by default set to 4. So press enter. And what that will do is only knit point cloud data that is within 2 meters of the LoCoBot. And that's good because the further, the further out data is from the camera, the less accurate it is. For this particular RealSense camera, actually, they say that the ideal range is between 0.3 meters and 3 meters, even though the max range is technically 10 meters. But just to be a little bit even more conservative, we're going to set it to 2. And I found that you get pretty nice point clouds just doing that. All right, so back to some of these tips. I've already mentioned this idea. You should not try to map out areas that are already mapped more than once in order to reduce noise. Because depending on your perspective, if you see the same thing from one perspective and then you see it from a different perspective, just because of the way the camera is seeing it, like you might get a lot more noise for the same part in the environment. Also, by reducing the amount of time that you're mapping, you're going to keep the size of the resulting database smaller, which is great because the smaller the database, the quicker you're able to load it whenever you want to continue doing mapping or do localization. Another thing to note is that for optimal loop closure detection, it's a good idea that the depth camera be tilted to the same angle that it will be tilted at when doing localization. And in general, it's a good idea for localization to have the robot camera pointed down slightly so that you can see obstacles and the robot will be able to navigate around them. So when you're doing SLAM, it's a good idea also to have the camera angled down slightly as well. Some other things to note before we actually go and do some of the navigation is the robot footprint. So if you look at this YAML file that is located in this directory, you can see over here, there's one that's called robot radius, which is currently set to 0.2 meters. This is the radius of the footprint of your robot. And depending on how big it is, you'll be able to do a better job of avoiding collisions with walls while you're doing navigation or other obstacles that are in your environment. So it might be a good idea that whatever your robot's radius actually is, you can like pad it a little bit within, an extra few centimeters or half a meter, whatever it is, just so that you're going to avoid collisions with walls and the like. Another thing to note is that there's a parameter here called max obstacle height. So right now it's set to 0.7, and this is for both the laser layer and the depth layer. I do a video explaining what these layers are, so you can look at that video to understand what's going on here. But the particular parameter I want to focus on is this max obstacle height. So essentially it's saying that if I see an obstacle that's above 0.7 meters from the ground, just to ignore it. And this is good because let's say I have a table where the top part of the table is more than 0.7 meters tall, then my robot will be able to navigate underneath that table. And I chose a more conservative value here, 0.7, depending on what your actual robot is. For the LoCoBot PX100 or the base version or even the LoCoBot Widow X200, the actual height of the robot is probably more around like 0.6 meters. And the Widow X250 version, the Widow X250 6-off version of the LoCoBot is probably a little bit taller than that, but still under 0.7 meters. So if you're working in a very tight area and you want the robot to navigate under tables that are pretty close to the top of the robot, you might want to lower that parameter. Okay, so that's enough about tips. Let's talk about doing actual navigation now. So right now I'm going to press the R2 key on my PS4 controller and it should move the robot. In my case, it looks like my PS4 controller isn't controlling the robot. It's not the computer, the LoCoBot is not responding, and that can happen sometimes. And the best way to get around it is to disconnect your PS4 controller by holding down the PS button until the LED turns off. And that'll take a few seconds. All right, and then after it's off, just tap it again. All right. So now I'm able to move the robot. And I don't know, I guess that just happens sometimes. It goes into a sleep state and you can't do anything about it except to turn off the robot and then turn off the PS4 controller and then turn it back on again. So here I'm just doing a little bit of a full circle. You can get a view of what the LoCoBot is seeing in the bottom left corner there. Now I'm just going to go straight, slowly. And then I'm just going to go left a bit. Like that. Okay. So of course, when you're actually mapping, you're going to map out your whole entire environment. Right now, I've only done a portion of it, but it's enough for you to get an understanding of how this is, how you can use the PS4 controller to do your, to map out your environment. So moving on in the Rviz displays, there's something called obstacle cloud. So if you look here, you'll see this rainbow colored point cloud. So that's actually being generated by RTabMapROS. It's taking an RGBD image and figuring out what the point cloud is from that. And it's being used by the move-based navigation package to figure out where obstacles are, so that if the robot was being, if you were doing navigation on the LoCoBot, like autonomously, not using a PS4 controller, it could figure out its way around obstacles. So that's what the obstacle cloud is. And then we have the move base parameters. So let's just uncheck the obstacle cloud here. And do a zoomed out view. So anything that's like here, this purple line, that's like a pure obstacle. The blue that is around it is a little bit less of an obstacle, more of a padding. The red around that is, again, a little bit more of a obstacle padding. And then the dark blue is even a lower cost for the obstacle for padding. And then anything that looks like this is pretty much free space. So this is our global cost map. The local cost map you can see here is like a 4 meter by 4 meter square that is around the LoCoBot platform. You can't really see it too much because of the point cloud map that we currently have going on here. But yeah, that's where it is. And we'll talk a little bit more about the global plan and local plan when we do the localization part. Okay. So now what we're going to do is talk about how to do SLAM if you're continuing mapping using an existing map. Okay, so we're going to Control-C out of the Rviz launch file. Then we're going to go to our RTabMapROS and Control-C that, and Control-C the joystick one. So now let's, to continue mapping using an existing map, we're going to type ROS launch Interbotix XS LoCoBot nav XS LoCoBot nav.launch. Robot model is equal to LoCoBot WX200. Put your own model there. If it's not that one, we're going to again use LiDAR to be set to true. And then R tab map args, instead of putting it to -D, which would start a new map, we're going to set this to this. R tab map start new map on loop closure true. So really, you don't need to set anything here you don't need to set RTAB map args at all. If you want to continue doing mapping, you can actually just leave that out. And by default, you'll start building a new map that will be tacked onto your existing map when SLAM starts. The issue with that is your new map will be started with no consideration of where your current map is. So what this argument does, this rtab map / start new map on loop closure, it'll first find out where your robot is with respect to your existing map. And once it figures that out, it'll start mapping for your new map. Okay, so we're going to press enter. All right. So we start seeing the message here at once a second, so we're ready to go. Let's get the PS4 controller package up. I'm just pressing the up arrow key in my keyboard to get the command to appear again, then press enter. All right. And let's start the Rviz monitor on your personal computer. Mine is called Demo Comp. Great. So what we're going to do is check the map, and then we're going to also go to rtab map ROS, check it, and go to map cloud. We're going to change the cloud decimation to 6 like we did before. Cloud max depth will be 2. And after doing that, check the download map checkbox. So it'll take a few seconds, but then eventually the map will be downloaded. And if you do have a successful loop closure, it'll already figure out where your robot should be in its current map, and it looks like it did it here. Now all you got to do is, using your PS4 controller, start moving forward. And you can rotate it. Move the LoCoBot into other people's offices and annoy them. Okay, so that's how you continue mapping using an existing map. So let's Control-C out from that. All right, the next thing I wanted to point out is doing localization. So to get started with doing just localization, we're going to type ROS launch Interbotix XS LoCoBot nav XS LoCoBot nav.launch. Robot model is equal to LoCoBot WX200. Use LiDAR. Again, if you don't have one, just set it to false, or just don't leave it. Just don't set it because it's false automatically. And then set localization to true. That's the important one here. So you might have seen that warning there. That's just our tab map trying to figure out where the pose of the robot is. All right. We're not going to be using the PS4 controller demo for this one because we're in localization mode. And in localization mode, you can, yeah, I mean, there's nothing stopping you from using the PS4 controller, but since you are in localization mode, we can use the functionality of move base for it to figure out how to get from where you want it to go, to get from its starting location to a goal location. All right, so let's start up Rviz again on our personal computer. Okay, check the map button. Let's also check our tab map ROS. Again, go to your map cloud, change cloud decimation to 6, max depth to 2, and then click download map. This will take a few seconds depending on how big your database is. So that's why I was saying it's a good idea to keep to make sure that your mapping is doesn't take up too much time and that you don't move the robot around too much, because then you'll have a database that could be hundreds of megabytes long or large, and it'll just take a long time to load it initially. All right, so here we have our point cloud representation of the environment. Let's also check the move base box. And here, what we're going to do is just give it a pose using Rviz of where it should go. So I'm going to tell it to go over here. It was a little bit hard to see over there, but there was a green line that represents the global plan of where the LoCoBot should be going from its starting pose to its final pose. And then there was a smaller red line that shows you the local plan, or, you know, based on where there might be some obstacles that weren't there at the time of the actual mapping, how to get around it. So if we go here, actually, you might see a better job of the of what those lines look like. So here's that green line. And then as the LoCoBot gets closer to it, you'll start to see the red line. All right. So you saw that red line over there, and that's the local plan. Okay, so that's using the 2D Nav Goal tool. Another thing you can do is also use the Python API to move the LoCoBot. I recommend usually using the Python API mostly in localization mode when you already have your map and you already know which locations are valid. So to get to that, let's just open up a new tab in our LoCoBot terminal. So we're going to go to ROS CD Interbotix XS LoCoBot Nav, just CD that into your examples Python demos. Then there's one that's called move base. So we're just going to edit that one. By default, it just instantiates an instance of a LoCoBot, and then it tells it to move to 1,1 relative to its initial starting pose where it started mapping. We're just going to tell it to go to an X and Y location of 0, 0, or essentially where it started. Then Control X, and remember you're going to have to change the name in there to be your model LoCoBot if it's not LoCoBot Widow X200. So then let's type Python move base.py. It should start an instance of it, and should actually start moving there. And we started, it was around here somewhere. So hopefully the LoCoBot should end up in the middle of this circle, facing that way. And it should rotate. Perfect. So that's two other ways you can navigate with the LoCoBot, either using the Nav Goal tool in Rviz or using the Python API in Python. That ends our tutorial for doing SLAM on the LoCoBot. Thank you for watching, and I'll see you next time.